Good morning, everyone. So today we're going to be finishing up the rest of those slides from section 8.1, and your homework tonight is going to be bookwork, so please check Google Classroom for that assignment. Now, we want to go over what cofunctions are. Well, in order to do that, let's highlight angle A first, and let's figure out what sine and cosine of A is. Sine is opposite over hypotenuse, so A over C. Cosine is adjacent over hypotenuse, B over C. And if we were to switch and now do angle B or beta, sine of beta is going to be opposite over hypotenuse is B over C. And cosine of beta is adjacent over hypotenuse A over C. Now, what I hope that you notice is that sine of alpha and cosine of beta ended up being the same thing, even though these were just arbitrary values. They're A, C, B, those are just variables, right? So it doesn't matter what is plugged in for them. And then cosine of alpha and sine of beta are going to also be identical. Okay, well, what is the relationship between angles alpha and beta? What is the relationship between those two highlighted angles? Well, alpha and beta have to add up to equal 90, right? So alpha plus beta equals 90 degrees. Well, what's that vocab? Complementary. So they're complementary angles. And that is going to be cofunctions, what we are referring to. So cofunctions of complementary angles will always be congruent or equal. So what we just learned up here was that cosine of alpha or sine of alpha equaled cosine of b, beta. Beta was the complement of alpha, and we got that by subtracting alpha from 90 degrees. So you could also see this written as cosine of 90 minus A or alpha. And then, well, if you find the reciprocal of sine, that's cosecant, right? So that just means that you've found the reciprocal of this fraction, this value, right? Well, then you would have to do the same thing here and find the reciprocal of cosine. So cosecant of alpha is going to equal secant of beta, which can also be written as secant of 90 degrees minus alpha. Now, the only one that has a little bit of a difference, and I'm sure you can figure this out very quickly, but, well, it's going to be tan. Let's just scroll back up real quick. What if we found tan of alpha? Tan of alpha is opposite over adjacent, so A over B, whereas cotan of beta is going to be opposite or adjacent over opposite, which is A over B. So you can actually see that cotan and tan of the complementary angles are going to be cofunctions. So tan of alpha is equal to cotan of beta, which is the same thing as cotan of 90 minus alpha. All right. So then here's an SAT type problem that uses this basic knowledge. So they tell us in the triangle above, well, sine of x degrees is 0.6. Okay, so here's x degrees. And now they want us to find cosine of y degrees. Okay, so they give you sine x equals 0.6, and they want us to find cosine, of y equals question mark. Well, we know x and y are complementary, and we know that sine and cosine are co-functions, so we know that sine of x is going to equal cosine of y. Sine of x equals cosine of y, so therefore cosine of y is also 0.6. And then this next SAT problem, so they tell us the figures are not drawn to scale. They tell us that sine of A equals cosine of B. Okay, and then they tell us an equation for A and an equation for B. And they want us to solve for the variable within those equations, which is K. Well, if we know sine of A is equal to cosine of B, well, the only way that happens is if those two angles are complementary. So angle A and B are complementary, which means that they add to 90 degrees. So A plus B equals 90 degrees. So let's take the equation we have for A and replace A with it. And let's take the equation we have for B and let's replace B with it. So that leaves us with 4K minus 22 plus 6K minus 13 equals 90 degrees. Combine your like terms, 4K and 6K make 10K. Negative 22 minus 13 leaves us with negative 35 equals 90. Add 35 to both sides. You get 10K equals 125. Divide by 10, divide by 10, same as just moving a decimal place over, so therefore K is 12.5, which is option C. All right. Next, real quick review, angle elevation is going to always be the angle drawn from the horizontal. So it's the angle above the horizontal since we are elevating. So it's the angle above the horizontal, whereas an angle of depression, since you are depressing, you're going down, you are going to be the angle below the horizontal. So I quickly want to just highlight this for you. So here is the horizontal. Angle of elevation is the angle going up from the horizontal. So this theta right here is your angle of elevation. Whereas on the angle of depression, here's your horizontal. So going down from the horizontal is your angle of depression. So here's our first example, a ship offshore from a vertical cliff. Okay, so here is my little boat. I'm quite the artist. And here's the cliff. So the boat is in the water. And I should probably make the cliff go into the water too. Okay, so we know that the cliff is known to be 100 feet in height. So let me put 100 feet here. And so a ship takes a sighting of the top of the cliff. Oh, well, it didn't want to work on this program, but you get the gist of it. So they get a sighting to the top of the cliff, and they tell us, so let me just finish drawing this right triangle so we know that horizontals and verticals make our right angle. Okay, so they tell us if the angle of elevation is found to be 25 degrees. So angle of elevation is always from the horizontal. Here's my horizontal. So angle of elevation will be going up from the horizontal is going to be 25 degrees. They want us to see how far offshore is the ship. So offshore is on the bottom of the triangle here, X. So if we're looking at the angle 25, we have the opposite side given to us, and they want us to find the adjacent. So we can use tan to find it. So we're going to be doing tan of our angle, 25 degrees, equals opposite over adjacent, so 100 over x. Now again, just like yesterday, we need to multiply by x on both sides, but then I need to get rid of tan of 25, so I'm going to also divide by tan of 25. Sorry, it's not wanting to sneak in there. So you know that that's supposed to be 25 degrees. So that means that we're over here, the x's are gone, and then you're dividing 100 by tan of 25. So x equals 100 divided by tan of 25 degrees. And just for time's sake, I'm going to tell you what that ends up being. It is 214.45 feet. Next. All right. So now we're going to be doing bearing which is just going to be using a notation that is a little bit different than what you're used to. It's used in navigation and surveying. Now, let me give you a few examples. So let's see if I try it this way. So if we are trying to find the bearing from a point O, so here's our point O right here, to a point P, okay? Let's see, so I'm going to draw this in for us. Let's say we want it from O to P over here. Okay. So let's say that's our point P. Well, the bearing from O to P is going to equal the acute angle, which means less than 90 degrees, between the ray, so let's turn this into a ray, OP, and the vertical line. So this is important. It's always to the vertical line that goes through O, which is that point that you're originating from. So it's the vertical line through O. Well, in this case, here's the vertical line from O. So let's say that they gave us that this angle over here was 70 degrees. Well, that doesn't tell us the bearing. The bearing is always from the point with the vertical line to the point P, right? So that's this angle here. But we know that that's a 90-degree angle, so if that's 70, then this is 20. And that's going to be what we use for our bearing. Now, the notation is a little bit different. So the bearing to point P is going to be 20 degrees, and we went to the east, 20 degrees east of north. So we went north, right? But we aren't true north. We went 20 degrees east of north. So we start by writing north and then 20 degrees east after it. So let's say we had another example of, let's go down here. I'll put an arrow this time. So what if we went over here and let's say that they gave us that this was 15 degrees. And let's call this point Q. So let's find the bearing from O to Q. Now again, we have to always do it from the vertical line that goes through O, right? So from O, the vertical line through O to that point Q. Well, that's this vertical line to that ray containing Q. Well, again, we have to subtract from 90 to get that this is 75. Now this time we went to the left, which is west. So we are 75, right? 75 degrees west of, well, we had been south. So we are 75 degrees west of south. All right. And our last example is going to be using bearing. So here's the word bearing. So we have a ship, it leaves port of the port of Miami with a bearing of 80 degrees east of south. So let's start by drawing in our axes. All right. So we had gone 80 degrees east of south. So 80 degrees means that we practically, I know it's not very straight, we went 80 degrees from the south to the east. So that leaves only 10 degrees over here. Then, and we also know that the speed is 15 knots and that they travel for 1 hour. So after 1 hour, so let's put 1 hour. So at 1 hour, we've stopped and we turn 90 degrees towards the south. So 90 degrees south is going to be this way. And then after 2 hours of maintaining that same speed of 15 knots, what is the bearing? So we went now 2 hours this way. And obviously it's not drawn to scale, but you get the gist. So we'll come as far down as I can. So after 2 hours, we want to know the bearing at this point. So we need to draw in our triangle. Well, our bearing is going to be from the vertical line to that point right here. So we need to find this angle. Okay. Well, in order to find that angle, this is our goal, we first need to find this angle right here. It's not that full 80 degrees because that 80 degrees was from the south, right? So that was including this little part here. So we need to find this angle here. we know that we traveled 1 hour at that speed of 15 knots and 2 hours at that speed of 15 knots, which we could have also written 15 knots here and then 30 knots here, but you know it's always going to be in a ratio of 1 to 2. So let's find this angle alpha, or A. So we have the opposite and the adjacent side. So tan inverse is going to give us what A is. Tan inverse of opposite over adjacent, 2 over 1, is going to give us the angle value for A to be 63.43 degrees. Okay, well, if I know 63.43 degrees, and I know this is a little neon, so bear with me. If I know that 63.43 degrees is angle A, I also know that this red angle here is 10 degrees. And I know horizontal and vertical lines always make 90 degrees. That means that the starred angle plus A, which was 63.43, plus 10 degrees will equal 90. So we can simply add those together and then subtract it from 90. So we can subtract 73.43, subtract 73.43, and we get that that starred angle there is 16.57 degrees. Okay, so now that I have that, I just need to write my bearing. So that means I am 16.57 degrees to the right, which is east. I'm 16.57 degrees east from south. And that is my bearings. All right, let me know if you have any questions. Sign up for office hours, email me, do whatever you need to do to make sure that you understand this. Rewatch some of the video if you have any questions, and let me know. All right, good luck, guys. Take care.